Stop breaking your monolith until you ask these 3 questions. If you're moving to microservices simply because your C# solution has become large, you may be walking directly into one of the most expensive architectural mistakes in modern software engineering: the distributed monolith. Imagine taking one reliable ASP.NET Core application and splitting it into 12 separate services. It sounds like progress, but suddenly, 12 services need to be deployed. Network calls replace simple method calls, failures can happen between services, transactions become harder, and debugging one request might mean tracing it across 5 different applications. You've added all the complexity of distributed systems without gaining the independence microservices were supposed to provide. Before extracting even one service, every senior .NET developer or architect should answer 3 questions. Number 1, do we actually have clear domain boundaries? Number 2, can our database survive being separated? And number 3, can our engineering team operate a distributed system reliably? Let's start with the most important one. Question number 1. Do you have clear bounded contexts, or are you simply splitting your folder structure? This is where many .NET migrations go wrong. You might currently have a traditional solution containing controllers, services, repositories, models, and data projects. Then someone decides, let's move to microservices. So the team creates an order service, customer service, inventory service, and payment service. On paper, it looks like microservices. But look at what happens when an order is created. Order service calls customer service to validate the customer. Then it calls inventory service to check stock. Then payment service to authorize the payment. And maybe shipping service before the request can complete. Now one operation depends synchronously on 4 other services. That's not true independence. You've taken dependencies that previously happened inside one process and moved them across a network. A safer approach is to prove your architecture before introducing network boundaries. Build a modular monolith first. Inside the same ASP.NET Core solution, separate your domains into clear modules. For example, ordering, inventory, billing, shipping. Each module owns its own business rules. Other modules should not directly reach inside its internal classes or database tables. Communication should happen through explicit public contracts, commands, queries, or domain events. Here's a useful test. Take one module and draw a box around it. Can you explain exactly what it owns? Can it evolve without developers constantly modifying 3 other modules? Can another module interact with it without accessing its internal implementation? If the answer is no, moving that module onto another server won't fix the architecture. It will simply make the bad architecture slower and harder to debug. First, create logical boundaries. Then, consider physical boundaries. Question number 2. Is your database actually ready to be separated? This is where many microservice migrations become painful. Imagine a traditional entity framework core model. Your orders table has foreign keys to customers and products. Inside your application, you can write a link query, use include, and EF Core generates the SQL joins. Simple. But now you extract orders into an independent ordering service. Customers belongs to customer service, products belongs to catalog service, and ordering owns its own database. That cross-service SQL join no longer exists. The database boundary has fundamentally changed your architecture. At this point, teams are often tempted to take the easiest shortcut. They create multiple services, but let every service connect to the same SQL Server database. Now you technically have several applications, but they are still tightly coupled through one shared schema. A database migration from one service can break another service. Your services are no longer independently deployable. True service autonomy normally means each service owns its data. So, ordering owns ordering data, inventory owns inventory data, customer owns customer data. Other services cannot simply reach into those tables whenever they want information. And this creates an important question. How do you query information across multiple services? You might need API composition, read models, caches, event-driven projections, or CQRS. Then comes the harder question. How do you maintain consistency? In a monolith, one ACID database transaction can update several related tables together. Across independently owned microservice databases, that assumption disappears. Now, workflows may require eventual consistency, asynchronous events, idempotency, compensating actions, or saga-style coordination. So before splitting a domain, ask, does this business operation genuinely tolerate that model? If the business requires a hard, immediate transaction across the proposed boundaries, those components may belong together. Don't split them simply because microservices sound more modern. Question number 3. Can your team actually operate distributed systems in production? With one ASP.NET Core application, debugging can be straightforward. You inspect the logs, follow one request, check application insights, attach a debugger. But imagine that same request moving through an API gateway, then 3 ASP.NET Core APIs, then Redis, then RabbitMQ, and finally another background worker. Where did the failure happen? Which service was slow? Was the message processed twice? Did a retry create another request? This is why microservices require strong operational foundations. You need distributed tracing with OpenTelemetry, correlation and trace context across HTTP and messaging, centralized logging, health checks, metrics, reliable CI/CD, and resilient strategies such as timeouts, retries, and circuit breakers. In modern .NET, those resilient strategies can be implemented using Microsoft's resilience packages built on Poly. You may also need an API gateway such as YARP or Azure API Management, and container infrastructure such as Kubernetes or Azure Container Apps. If deploying one application reliably is already difficult, 10 independently deployed services won't solve the problem. They'll amplify it. Now suppose you've passed all 3 tests. Your domain boundaries are clear, your data can be separated, and your team has the infrastructure to operate distributed services. Should you rewrite the entire application as microservices? No. Avoid the Big Bang rewrite. Instead, use the Strangler Fig pattern. Here's a practical .NET approach. First, place a reverse proxy or API gateway in front of your existing monolith. For example, you can use YARP, yet another reverse proxy, with ASP.NET Core. Initially, almost all requests still go directly to the monolith. Your users don't know anything has changed. Next, identify one domain with a clean boundary. Not 5 domains, 1. A notification component is often easier, or perhaps a payment capability if its responsibilities and data ownership are already well defined. Build that functionality as a separate service using .NET 10. Give it independent storage where appropriate. Introduce asynchronous messaging when the workflow actually benefits from it. MassTransit with RabbitMQ is one possible implementation. Then update the YARP route. Request to something like /API/payments Now go to the new service instead of the old monolith. The client URL doesn't have to change. Once the first extraction is stable, repeat the process. Choose the next bounded domain. Extract it. Redirect its traffic. Measure the results. And keep shrinking the monolith gradually. But here's something architects sometimes forget. The goal is not to eliminate the monolith at any cost. If the remaining application works well as a cohesive modular system, keeping part of it as a monolith can be the correct architectural decision. So remember the 3 questions. 1. Prove your boundaries with a modular monolith before introducing network boundaries. 2. Decouple your data model and understand how consistency will work before separating databases. 3. Build observability, resiliency, deployment, and operational maturity before multiplying your services. Microservices are not an upgrade from a monolith. They're a trade-off. You exchange some development simplicity for independent deployment, scaling, ownership, and organizational autonomy. And that trade only makes sense when your system actually needs it. This is part 1 of our .NET System Design series. In the upcoming videos, we'll go hands-on with C# and implement YARP reverse proxies, distributed messaging with MassTransit, Saga patterns, and CQRS. If you're preparing for senior or lead .NET interviews, subscribe to the channel and check the LinkedIn newsletter linked in the description and pinned comment. We share weekly system design cheat sheets, architecture diagrams, and practical .NET breakdowns. Subscribe, and I'll see you in part 2.